It's a privilege to share some of the work we have done here in Manipal University to increase what everyone talks about: industry, academia, collaboration. And the approach which we experimented since 2015-16 batch, and then repeated again for the current batch 2016-17, uh, was to look at how we can take the full semester internship program, which we have had for several years, and build a collaboration between the industry and make our students industry ready. And I will proceed into the approach which we have taken. So what we found was that not only in our department, automobile engineering, we had in all our programs, as is common across several engineering programs, that we do offer final year internship program, or we offer a summer internship program in some cases. Uh, the deliverables for that program between the sponsoring industry and participating students are largely undefined. The trend is, the students arrange the internship, or colleges do that through their MOUs or partnerships which they have. And what we found was that the internship program is like a burden on the industry, and therefore, in fact, many sponsors are charging money to take on internships because they feel that some of their time is spent and they should be paid for it, which tells us a story that the industry doesn't see that what value do they get out of this human resource, which is raring to go. They have a lot of energy. And the students have over the years perceived that this internship semester is really a time for us to appear for GRE and GATE exam, etc. And so they take it as a downtime. And so the entire benefit of what an internship really means is being lost. So we felt very strongly in the automobile department that this is an opportunity for a student who's ready to get into the workforce to become industry ready. And with my past experience in training large number of people with Lean Six Sigma methodology, uh, I took upon myself to integrate the methodology into the internship program. And for that, as the methodology, those who have practiced it will realize there is a period of time required for defining the projects. And in the Lean Six Sigma, which I will show you a few slides later, the definition phase is very important because it sets the expectation between your sponsor and the project team, which is in our case the students who are going to go to that company. So what we started doing was, in the prior semester, the 8th semester, we had 1 credit for technical seminar. We converted that into introduction to Lean Six Sigma, with ending and getting the credit if you are able to define a project with a sponsoring company. And for this, it required us to reach out to different industry sponsors in advance and begin what we call the collaboration. That what can we deliver through our Lean Six Sigma training, which we provide to the students, and what the industry will gain out of our students coming to them. So that's why I call it industry academia collaboration. This was 7th semester. So what the benefits you see from this restructured internship program was, now the industry sponsors view students as a resource to fill an execution gap. Now, as many of you know, that in the industry they have a lot of projects which need to be done, especially problems to be solved. But because they are into a culture of firefighting, they're reacting to the latest problems without getting into the root cause and putting a permanent solution in place. They go into this cycle of just reacting and firefighting. Very experienced people are making the same decisions, and they will be consuming a lot of their time and energy. So when we reach out to the industry and say, we have students who are trained to solve a problem using a structured methodology like Lean Six Sigma, they immediately grasp upon it. Now, all the sponsors are not aware about Lean Six Sigma, so that is a hurdle where we try to explain to them how it works. And this allows us to get our faculty to become advisors on the project. And mind you, our faculty are not experienced in Lean Six Sigma, but it is learning and applying. So they also, because they are more experienced with different ways to solve problems, they are able to start using the Lean Six Sigma method and guide the students so that the students are not left depending on the sponsor. What we find, if you look at the NBA graduate outcomes, one of the key outcomes is to have a problem-solving capability. Now, this is something which in the academia we have not really understood what problem-solving capability really means beyond that. Do I have the ability to solve problems in my theory courses or different practicals? When you go through structured problem-solving methods, you really are able to solve real-world problems, and a student is excited and that the problem assigned to them is a real problem the industry is facing. It could be a quality problem, it could be an inventory, excess inventory problem, or unable to meet customer requirements. It opens up a lot of other avenues. And the other aspect about the Lean Six Sigma approach is that it introduces what we call time-bound critical thinking. Because I can do critical thinking, but if there are no time limits to it, I may be too late with my solutions, which again is as a professional in the industry, you're expected to deliver certain results in a certain amount of time. So what we started, our internship program already was awarding 21 credits. And this was based on the project management and accountability behaviors our students did. And this is reviewed at the end of the semester through a very rigorous project review where the student may have to come back 2-3 times during the week of the presentations to answer some of the questions he was unable to answer in the first presentation. So, so if I just go through the steps which one needs to really emphasize on, the first is, as I mentioned earlier, project identification and selection framework. As those who have taught lean manufacturing and other lean set of tools, there is a very powerful tool called value stream management, in which you map the customer value at every step of a process, whether it's manufacturing or a non-manufacturing process. And these mapping of an end-to-end process in a business or in a manufacturing area helps the business or the sponsor to link strategy with the internship project. Because if the project is not critical to them, the project never gets that kind of attention. It never gets the support. Because for them that project is not really going to help them immediately. So what we did was, for example, when we started this program, we collaborated with industry like JCB, which is in our area, and started establishing a memorandum of understanding to train their leaders on value stream mapping. And we finished, identified 3 internship projects for 9 students, 3 per project. We did the same thing with Mahindra tractors, and through that mapping we were able to identify 2 projects for 6 students, which were related to reducing inventory and lead time. We also reached out to a startup enterprise, CarServe, which was looking at servicing vehicles at your doorstep, and their process required a lot of automobile engineering knowledge. And we identified 3 projects to establish a lean process that can you do it just in time, as they say, JIT. We also, in our city, we have carbeco.com, as some of you have used it to evaluate different vehicles, and they were launching a new app called Car Buddy, and they were willing to assign 2 students to develop their new app. And it is based on automobile working knowledge, so that a user, a driver, or the user of a vehicle can get all the information needed through different screens, and that required someone with that automobile background. We also were successful with Magneti Marelli. They used the value stream approach, and those students did a great job there. So I'll just go through some of these examples just to give you an idea. At Maruti Suzuki, there's a lean project to reduce material cost. So your sheet metal, which they use for the body, car body, they wanted to reduce the thickness where possible. So that required some amount of analysis, and that was a pretty successful project. Now, if the list goes on, Jukin is another supplier to the OEMs. They assigned a project to reduce lead time to manufacture the parts they supply to Maruti. Eicher Tractor, this was a very interesting project where there were several non-value add steps in their assembly line, and therefore this project was assigned to a student. And Escort, we were able to improve quality by reducing defects, which is Six Sigma approach, through 4 students who actually delivered those results. At Tata Pune, there was a project to improve the quality of the utility vehicle at Tata. Volvo Eicher, we also were able to reduce assembly time of light and medium duty vehicles by looking at non-value add time which they had in their process. Honda diesel engine cylinder head. So these, the terminology, the problem-solving approach, which is given to the students, is, I'm sorry, I'm going the wrong way. I will show you how we train them. These are, again, this is a list of different, in fact, we had 2 students go to Otago, New Zealand as exchange students, and they used a design for Six Sigma for the electric vehicle project being developed in their research labs. We also sent students to dealerships for reducing time of service through a process analysis. Same thing, these are 2 dealers, 3, most of these are dealers to reduce the servicing time. And so that was, I just wanted to share with you some real life projects which were done in the first batch. The second batch just completed their projects, and next time I get it, I can update the type of projects they did. But for those who are wondering, okay, Lean Six Sigma, we have heard about it. Why does it deliver results? We call it a structured process improvement problem-solving approach. And the structure is based on that, not jumping to improving or solving a problem, which is a human tendency, without spending time to define the project or the problem and measure, where you are, what is your baseline, what is the gap to your target condition, and then analyze the gap to find out what are the risks, what are the root causes, where is the waste creating that gap to your target condition. Once you understand that, then it becomes very relevant and very intuitive to identify what improvements you have to make. But you just don't go and improve them, but you identify what are your critical inputs in your process. You do design of experiments, and you pilot your new process. And then finally, you have to sustain the changes, because once the project is over, you hand it off to the process owner, and you therefore finalize what is going to be your control plan or your control system, and how are you going to control your long-term capability. So that's a very quick overview of the Lean Six Sigma roadmap. In popular terms, it's called DMAIC or DMAIC. And this is the process or process or problem-solving approach, which is popularly used in not only automotive industry but other leading industries, as you may have found. As far as how we structured it, and as I mentioned to you, Our curriculum in the seventh semester was a one-credit curriculum for technical seminar, and we redefined it and we call it that as a pre-work. This is going to be a pre-work for your final semester's internship, and as these steps are shown here, the purpose would be to select a project with buy-in from an industry sponsor, so that when you do go to your sponsor, you already know this is a project you're going to work on, and they're not wasting valuable time, because you just have a semester worth of time. If you spend 3-4 weeks just trying to find the project, basically you short 1/3 of your time which you had available. So that's why this is a very critical step to do it one semester in advance. And this also establishes the accountability between the industry sponsor and the student intern before they begin their eighth semester. So what we do here during this pre-work is, since the students have entered into this different approach towards problem solving, we do give it's a 2-hour a week of lectures and practices to introduce Six Sigma, Lean, and Lean Six Sigma. So these are the actual methods, and but just more at an overview level. But our focus is on how does a company link Lean Six Sigma to strategy and project selection. So the student needs to understand how a project would be selected at the company where they would like to work or are thinking of going to do their internship. This way, when a project is assigned to them, they are already aware if the project fits a strategy of the company or if it does not. This way they can negotiate a project which is more meaningful by having an understanding how this linking is done. And then, just like I showed you at a very quick look of the different roadmap phases, we go into each phase and talk about some of the tools and some of the learnings, deliverables necessary to move from one phase to the other. And towards the end of the semester, we have to be able to define a project and develop that and present that project charter to obtain your 1 credit. And this, what we call, is readiness for your final semester in the internship program. So in the final semester, the 8th semester, what we did is, instead of just telling students that, okay, after your break, go directly to the company where you're going to do the project, we call in the students for a week. We call it pre-internship week. And this is 5 days concentrated just studying about Lean Six Sigma methods and the actual tools and practicing them in the class or in our lab. And what we do in the first week, which is this, we only stick to the define and measure phase, which you saw earlier, because that is what they will be working on when they go to the company initially. And these are some of the tools which are listed out. And these tools are used industry-wide. I mean, you can go to any industry when you talk about Lean Six Sigma. These are the same tools they would be using. So we have our students practice it during the 5 days. They end the week with a sessional exam. So, on the 6th day, they are giving a regular sessional exam, which becomes their first sessional. And we insist that our faculty advisors who are associated with the students also attend this class so that they can start integrating with the students who are on their, whom they are going to be advising in terms of what their project is and how you're going to define and measure it when you go back to your company there. So now the students go and do their project. For 4 weeks, they are working on the define and the measure phase. So basically, they end up with a good idea of what is the baseline conditions, what are the critical to customer requirements, and using some of these tools to lay down what is the gap between the baseline and the future state which the project is promising to deliver. And when they come back, now we focus on the analyze, improve, and control. So they make a presentation as they come to the campus on what they have done during their first 4 weeks on site with their company. This puts a deliverable on the students that during those 4 weeks you have a very tight schedule, because when you come back you will be evaluated for the work you have done so far. So in terms of continuous evaluation, they have to be able to show what work they have done. And marks are awarded for that from the internal assessment category. And then we are training them on using uh, the tools required for analysis, improve, and control. And these are some of the typical tools where we practice with the students. And mind you, these are again the tools which an industry which uses Lean Six Sigma is very familiar of. And when they know that students are coming already trained on this, they feel very comfortable in engaging the students and then providing some mentoring, not trying to teach them from scratch. So I think what we are offering the sponsor is that the students have the knowledge, they need to apply it, and that's where the sponsor can help them in the application. And at the end, they get a benefit that their problem is solved or their process is improved. And so that is what we do in the mid-internship week. So just to recollect, the semester starts, the first week is spent in campus, then for learning about how to define your project, how to measure it, because what we did in the 7th semester for defining a project was something through long distance. But when you go there, you then cross-check and validate the definition of your project, and then start measuring the baseline. After a month, 4 weeks, you come back and do a mid-internship week where you learn about analysis and improving a process and how to control it. Now they go back and finish their project. So it's usually another 2 months, a little shy of 2 months, they get to finish the analysis, and then they improve and the control. So this is how we gave them the knowledge and how they applied it. What we have is that this is the entire schedule which we explain to our student sponsors. And during when the student is there in the second phase of their project, we send our faculty advisors to companies where a significant relationship needs to be built. And the faculty advisors go meet the students, meet their mentors, and see, what are the challenges they are facing, and are there potential for more projects in the future. And now that we have gone through 2 iterations with some of the companies I mentioned earlier, we've started seeing there's a pull from some of the companies, not all of them, for us to send our interns to do their projects there, because they find that there is a value. And so that is how we started approaching this collaboration with there. So I'm happy to take any questions if you have. So Sridhar, I don't know if you saw any questions or.
how do we implement in traditional curriculum for first year?
For first year, you mentioned, Surya?
Yes.
So we implement what? Lean Six Sigma or the internship program?
Yeah, I hope they will clarify.
So the first year, I think the individual is probably asking about the mini project and major project approach, which a few programs I have started practicing to apply the knowledge which is being taught through these several semesters. I think that is a different. If I'm guessing the meaning of the question, that is to actually learn and apply your the theory which you are learning for your particular program. What this approach is to make you industry ready in terms of problem solving capability, which is one of the graduate outcomes where I think it's very difficult to apply it because you need an industry level problem. Now, if I was going to do this from the first year, which sometimes is possible, we probably will struggle in finding sponsors who are ready to take the first year or second year students. Now, what we have started doing with our second year students and third year students from last year is that when you go for a summer internship, because we do have that also, you get 1 credit for a 45 days summer internship. We are asking our students to start using that summer 45 days to get acquainted with the company, understand their processes, and then identify their challenges, which then will feed into your project selection and project definition, which begins in the 7th semester. So I'm assuming a lot of things from what the question was asked. So we are using our summer internship now. As we get more and more mature in this process, we're going deeper into our summer internship. So for example, students who completed their third year and were entering fourth year, they had a summer. This summer is just is ending. Quite a few of them have gone to companies and started doing mini projects at the company, where it was a small quality problem which needed to be solved. But doing so, they started understanding what is the project pipeline the quality department, for example, has, or the production department or the design department has, and then start building that relationship with the company and the mentors and say, I would like to come back and do a full semester internship with you. And in between, we can stay in touch and help define a project which I'll be ready to start working on. And so that is how we have encouraged the summer prior to the 7th semester. Now we have some enthusiastic students from second year who also went to different companies for their summer internship. And they have started even earlier, but they are only in the single digits. They are not double-digit number of students. So I don't know if I answered that question as it was intended.
So the next question is it applicable to diploma students?
Pardon me, sir?
Is it applicable to diploma students?
Yeah, so this Lean Six Sigma practice is, a diploma holder may not be able to learn the Six Sigma Minitab statistical analysis, which I don't see why you can't, because the training does simplify it quite a lot. Diploma students can definitely take advantage of it if they have, I'm not sure of the diploma program having a summer internship, or do they have 1 year internship at a industry. Some diploma colleges probably do have that, which are skill development university type or skill development centers. But I don't see why a diploma holder cannot use these practices, because this is, in my experience, I was training individuals who are non-engineers also in learning how to solve a problem using critical thinking. So
The next question is, how were project deliverables evaluated? Were any guidelines given to students or faculty?
right. So that's a good question. So the define phase, as I was mentioning, there you develop a project charter. It is actually a project charter where not only you define, what is the project scope and what is the business impact, etc., and what is the opportunity or what is the problem you have to get over. You are actually establishing the primary metrics and secondary metrics of your project. Those metrics are deliverables that you will change a particular metric from its current baseline to a target value. Example, since most are having an engineering background on call, quality is usually measured at a high level as defects. So the company will say, okay, in this particular process or this particular design, we have X percentage of defects. We want this project to reduce the defects by 50% or 60%. In Lean Six Sigma, we go for breakthrough goals because that allows us to apply, certain rigor in the analysis phase and the measure phase. So there we set the target before the project starts. So I know the baseline, I know the target. Now this was in the beginning. I have not set foot into the factory or the business. Now when I go after that 1 week of training as a student, I go and reaffirm my defined metrics because I already have a rough idea of what I'm looking for. Now I'm just validating that is this the target we want to look. Now many cases the baseline is kind of very hazy, it is gray. So the measure phase is intended to validate what is your current performance, what is your current baseline. So if I was doing a quality reduction problem, quality improvement problem, then I would know, okay, the defects which you told, while we were talking to you, you thought it was 10%, but actually you're 25% defects. Yeah, these are shocking numbers when you start measuring the actual defects. And therefore the target will be to bring down the 25% to say 10%, because in a limited time frame of the semester, you may not be able to get after all the causes for those high level defects. So the deliverables are evaluated on how well you achieved your target condition, which was set through the primary metrics and secondary metrics. In some cases, there may be some genuine issues where the company cannot implement some of those changes. In the improve phase, you are supposed to pilot your changes. So in some cases, in a difficult situation, we say, okay, can you pilot it for a few, sample conditions and show there is a potential to reduce the defects. And the company manager who is mentoring this person says, you know what, I have faith, we will implement this and we will see that much reduction. So if the company, the sponsor certifies, says that this project has value for them, that means the deliverables are being achieved. And in the control phase, the student has to prove that the change he or she made was statistically significant, or through a lean method, visually discernible, or you can visibly see that there was a major change in your process if you're not using statistics. So that is how we evaluate the deliverables at the end. So just as a further idea about the project deliverables, we don't award green belt certificates to students who have not been able to deliver their projects to the sponsors' ability, or have not used the tools necessary to come to the results. So you may have got the results by fluke, but you did not use any tools. You could not prove to us that you have used the tools, and therefore we don't feel that you deserve your green belt certificate. You will get your credit, you will get the marks, but it won't be rising to the level of A grade in which you will get a certificate. So, for example, the first batch, only 14 students out of 42 received a green belt certificate. From this second batch, which just completed, 24 of the 39 now have received. So we have seen an improvement in terms of how the students are taking it and how our faculty advisors are also helping the students. So.
Thank you, sir. That was the last question.
Okay, thank you. It was a pleasure to share, and if you need any further detail, I'm always available with my email on Manipal website. Also, you can find my contact information, Manipal University Jaipur website, and appreciate the opportunity.
Thank you, sir.